So for that, the quick easy way instead of guessing is just do the Wronskian. So we have two parts of this, so we just have a little 2x2 guy for this guy. So the y1, recall, was x squared, and y1 prime was a 2x. y2 was an x squared natural log of x. y2 prime then was 2x natural log of x plus x. So those were results from the previous page. So hopefully you remember your matrix work. So for a little 2x2, downward diagonal minus upward diagonal, so W is x squared by this 2x natural log of x plus x minus upward diagonal 2x by x squared natural log of x. So Wronskian then, we have 2x cubed natural log of x plus x cubed minus 2x cubed natural log of x. So our Wronskian is x cubed. Well, you might think, well, that can be 0 if x is worth 0. But recall the interval that we're working on, we were working on zero infinity with this guy. So 0 is not a possibility for x at the moment. So 0 doesn't exist. So this is non-zero for all x on this 0 infinity domain that we've got. So since it's non-zero for all the x's on the domain, this means that yes, they are linearly independent. So we are happy with our homogeneous part of the equation. So now we just have to check the particular part of the equation. So our particular part was 1/4 x to the 4th. So our particular prime would be x cubed, and particular double prime is 3x squared. And we test that out in the original differential equation. This time it's the particular part, so we do keep the non-homogeneous part. So we keep the x to the 4th instead of a 0 on the right-hand side. So then x squared y double prime, x squared by 3x squared, minus 3x times y prime, so minus 3x by x cubed, plus 4 times y, 4 times 1/4 x to the 4th, and we want to know, is that worth the x to the 4th, the original g of x on the right hand side. So 3x to the 4th minus 3x to the 4th plus x to the 4th, possibly worth x to the 4th, and sure enough, x to the 4th is equal to x to the 4th. So that one works out. So we have confirmed then. We confirmed each piece of the solution works in the original. We confirmed the homogeneous parts are independent. That's enough to prove that this is the general solution. So yes, the y equals c1 x squared plus c2 x squared natural log of x plus 1/4 of x to the 4th is the general solution to the given differential equation. Just one more little mini review. I think there's maybe one or two with a 3x3 Wronskian. I just want to run through one of those quickly. Let's say y sub 1 is, we'll just do small ones. Y sub 2 is e to the x, and y sub 3 is x cubed. So our Wronskian for that First row would be an x, an e to the x, and an x cubed. Then we differentiate each, so 1 e to the x, 3x squared. Differentiate again. When you have a 3 by 3 determinant, recall that we would just sort of pick one, cover that row and column, and make the 2 by 2 that goes with it. So e to the x, e to the x, 3x squared, and a 6x. So that was covering this row in this column. X was what I covered. I brought that out there. And then we just keep alternating signs. So then minus, and then we move along either the row or the column, your choice. In this case, I'll move along the column just because I'll get to knock something out entirely. So then I have a 1 that's sort of in the hot seat. So now I'll cover up the middle row along with my first column and make my 2 by 2 determinant that way. So I'll keep the e to the x and the x cubed, and I'll keep the last row e to the x and a 6x, and then flip the sign again. So now plus, and now it's 0 times, and I don't really care what goes in there. It happens this time. We cover up the last row in the first column, so we have a pair of e to the x's and an x cubed and a 3x squared. But 0 times anything is going to drop that guy off. So this guy, our Ronskin, would be x by 6x e to the x minus 3x squared e to the x minus 1 times 6x e to the x minus x cubed e to the x. So our Ronskin then looks like everybody's got an e to the x, so I can grab that. 6x squared minus 3x cubed minus 6x plus x cubed. So our Ronskin for this guy, e to the x by, let's see, x cubed, negative 2x cubed plus 6x squared minus 6x. And then we go on to see if this is non-zero on the given interval. So I just did want to kind of show you a quick reminder of how the 3 by 3s are done as well. And you won't be given anything bigger than that. Bigger than that, you would go to a computer algebra system. So 1 through 35 on the odd should be plenty of practice with these. If you have any questions, please get in touch. Otherwise, I'll see you next time.